So what is the potential difference between A and B due to the charge shown? So we have two different points in space, and we want to find the potential difference between A and B. Now, what we don't know is we don't know if we're moving from A to B or B to A. So whatever we may get a negative, may get a positive. It doesn't really matter. We just want to find the potential difference from A to B. So to do this, pretty straightforward. Use that equation. We want to find the potential difference from A to B, which is really just finding the electric potential at B, and we minus the electric potential at A. Now we did electric potential already. We have an equation for electric potential. Now remember, we're talking electric potential, not electric potential energy. So we have our KQ over R. Now, if we're talking about point B, that's the B value, how far away it is from the charged particle. And we're going to minus KQ over the radius at point A. Well, we can see that this equation simplifies down. We can do some factoring. Factor out the KQ, and it's just the 1 over RB minus the 1 over RA. And at this point, all we have to do is plug in our numbers. Like so, we have our K value. Q is our charged particle of 8 microcoulombs. And all we have to be careful about is we put the correct radius in. RB is the 0.50, RA is the 1.0. And in the end, what we find, 2 sig figs, is we get 7.2 times 10 to the 4 volts. And that is the potential difference going from point A to point B. Now, if we went the other way around, well, then we would get a negative value. And those positive negatives are going to come in handy as you do more with electric potential. For right now, it doesn't really matter which one we get because we don't know if we're moving from A to B or B to A.